All right, well, let's talk about circles. And I guess before we talk about circles, let's first do this bell work, because it really is a good work type problem that could show up on a test, or at least one similar to it. So let's go ahead and start setting up our work type, chart. So just as a reminder, for our work type problems, they're almost always the exact same chart, where we kind of have these three columns. There we go. We'll put something over here. Now, every single time we're doing a work type problem, we're always going to have some kind of rate or speed at which the object is working or the person is working. Then we're going to have how much time that object or person gets to work. And we do that multiplication, we see how much work is actually done. I like to relate that to kind of our speed problems, where we have rate times time equals distance. It's the same thing. The rate at which I work for the amount of time I have to work equals how much work I'm actually going to get done. In this particular problem, we actually have two pipes. We have pipe number 1, we got a pipe number 2, and they're both kind of doing some work. So let's go through the problem. So it says one pipe can fill a pool 1.25 times as fast as the second pipe. When both pipes are open, they fill a pool in 5 hours. So working together, they fill a pool in 5 hours. How long would it take to fill the pool if only the slower pipe is used? So this is a little bit different, because usually we start with, we know the individual rates and stuff, and we figure out how much work is actually done if they're working together. So we're going the opposite direction. We're given how much work they can do if they work together, and we have to go backwards and solve for 1. So let's go ahead and start with that first sentence. One pipe can fill a pool 1.25 times as fast as the second pipe. So this is a good chance to put an X down for our pipe 2. We'll put a 1.25 for the rate of pipe 1. That way pipe 1 is working 1.25 times as much as the other one. Now let's put information down that they talk about how long it takes them to fill a pool. So when both pipes are open, they fill a pool in 5 hours. So in that sentence, we have both of the pipes working for a total of 5 hours, which means the amount of work that pipe 1 does is 6.25x. Because we're going to do that 5 times that 1.25. The other one, 5 times x, we have 5x. So as we're working with time of 5 hours, pipe 1, which provides 6.25x amount of work, plus the 5x provided by the other pipe, will fill one pool. So it says they can fill one pool in 5 hours. So that's what that table is emulating. So let's go ahead and solve for x. So we'd have 11.25x equals 1. Divide both sides by 11.25, and we have x equals 1 over 11.25. Now, we solve for x. Now we have to ask ourselves, what does x mean? Well, if we look back here, x is actually the rate of pipe 2, which is our slower pipe. I guess I should have noted that here. This would be our slow pipe. That says pop, slow pipe. And that equals 1 over 11.25. Now remember, what these rates are actually saying is they're saying they can do one item, one task. In fact, this time, instead of task, it is basically one pool per time. That's how rate works. It's in like miles per hour. It's an object per time. So this can fill up one pool in 11.25 hours. So the slow pipe can fill one pool on its own in 11.25 hours. And if we multiply that by 1.25, we could have figured out the faster pipe as well. So that is our pipe problem. Let's go on to circles. All right, actually, real quick, before we get into circles, we do have to talk about completing the square, because completing the square actually comes in a little later in this lesson, but I want to rehab kind of what happens when we're completing a square. Now, when we complete the square, we basically want to turn this binomial, which is x squared plus bx, and I want to figure out what I can add in here so I can rewrite it as something squared, i.e. completing the square. So what number goes in there so that I can have x plus something squared? Well, what we're going to insert here every time is we're going to take that coefficient that's in front of x, which is our b value, and we're going to do that divided by 2. So we're going to have b divided by 2 squared. Now what we can do with that b over 2 is we can now insert just the b over 2 into here, because we're going to note the squared is already taken care of out here. So if we ever have x squared plus bx plus b over 2 squared, we can always rewrite that as x plus b over 2 squared. Now once again, it's kind of arbitrary if we're just doing it off to the side, but we're going to see why we're going to need this in a little bit. But here, just a couple examples of this, and we're going to use these exact examples a little later on when we're looking at a circle. So this says complete the square and then factor it. What they're asking for is, first of all, find that third term. So now remember, it's b divided by 2, so it's 6 divided by 2 squared. Now, the hard part I see all of the time is people, when they ask to factor it, will actually go x plus, and they'll put in the 6 divided by 2 squared, and then they'll square again. That is incorrect. We just take the 6 divided by 2, so 6 divided by 2 on its own, and the squared goes on the outside. So we have to remember that the squared goes to the outside, just like with the x. It goes to the outside. So simplifying that, that would just be x plus 3 squared. A little more complication comes in when we have a negative number. Now note, it's b divided by 2. Our b in this case is actually a negative 5. So our b divided by 2 will be negative 5 divided by 2 squared. Now when we factor this, it's going to turn into x minus 5 over 2 squared. A little thing that will help you remember this is, in order to have this negative, we needed to have a negative inside of that squaring function. So in order to have a negative, I must have had a negative there. So I'll see a lot of times people, while they're factoring, will just circle that negative and put it right there so they remind themselves in case they forgot it within the actual negative 5 over 2. So that gives us x minus 5 over 2 squared. Can't really simplify that, so that would just be our fully factored version of it. All right, we're going to put a pin in that for a second. It's going to come back in a couple examples. But right now we're actually going to dive into the distance formula for a circle. Now, as a reminder, a circle really is just a shape that's the same distance wrapped around a point. Now that distance we often call, and I'm going to write this on here, is a radius. So a circle is, if you remember when you use your little protractors or your compass, and we spun that around, our circle is that set of all points that are equidistant from that center point. Once again, known as a radius. If I would draw that all the way across, not really important to us right now, but that would be called a diameter. So that would be a diameter if I extended that. So we have a radius and we have a diameter. Now we're coming up with a formula for a circle. Now the formula for a circle must be kind of something with distance, because in its definition is that equidistance from that given point. So it kind of makes sense that we're just going to get that distance of our radius with kind of our variables x and y, which is going to result in this formula here, where, remember our distance formula for 2 points? Where our distance, we usually call distance, we can see that up here, equals that a squared plus b squared, and we take the square root of both sides. Well, those are subtracting our x values and y values. In this case, we're going to do our x values, which are x and h in this case, because if we look at our central point, our h is in our x spot, and our k is in our y spot for our central point, squared, plus our y value is y for our first point, and for our second point we have k in that y value, so we have y minus k squared. Now for this formula, our x and y will remain. However, I will point out that h and k are the center of your circle. H and k are going to be the center are the center x and y values. So these will always be numbers, or for the most part, these will be numbers. These will be like 3 and 4. Our x and y will be our variable. Our h and k are representations of numbers that we'd either find or know in the problem. Now, that comes from the distance formula. Another way that a lot of people write this is actually where they actually move the square to the outside. So they take the square of both sides and they go with r squared equals our x minus h squared plus y minus k squared. I am going to note that a lot of times this is the one people are looking for. This is known as our standard form. Once again, x and y are going to be our variables. R, h, and k should all be numbers if I want to actually have that circle defined. So x and y variables, r, h, and k are going to be our numbers or our constants. All right, so that's that formula we're going to use throughout the rest of this lesson. So our first example is sketch the graph of this particular equation, reminding ourselves that it comes in standard form. Now, the weird thing about standard form are the fact that we need to have these subtraction signs. The other thing I want to point out is it is r squared. So don't just circle the very right thing and go, oh, that's my radius. 9 is not our radius, nor is plus 2 going to be our k value. Instead, let's rewrite this to match that formula. So rewriting it to match it, we should have subtraction. We'll still stick with that x minus 1 squared, but we're going to turn this one into y minus a negative 2 squared. And we're also going to note that we would need to take the square root of 9, which would turn this into 3 squared. A lot of times we don't write this. I'll go over that in just a second, but this would be how it's written with the squares all in there and our subtraction signs. We now have a circle where we know the center point. Our center is going to be the point 1, comma, negative 2. Our radius is going to be, and like I said, we can pick out from that second one that it's just 3, but more often than not, we just kind of realize it comes from the square root of 9. So most of the time when I ask for the radius, just take the square root of that number, and that's going to be the radius, just in case it's not like a nice, clear 3. Maybe it's like square root of 2 or something. So these are important facts, our radius and our center. I'll also touch upon really quick, your center, let me erase this really quick. Your center will actually make the different parts equal to 0. So if I plug a 1 in there, 1 minus 1 is 0. So 1 is the correct value. If I plug a negative 2 in for that y, negative 2 plus 2 is 0 once again. That's another way we can remind ourselves of the fact that we can't just take whatever value is there. It's got to be minus. It's got to be x minus 1. It's got to be y minus a negative 2. Or, like I said, just figure out what needs to make it equal to 0. So for x minus 1, 1 makes it 0. Y plus 2, negative 2 makes it 0. Our center is at 1, negative 2. Let's go ahead and graph this. So we'll graph with our starting point, which would be 1, negative 2, which would be right here. There's our center. Our radius is 3, so we're not looking for perfect. I don't need you to take out a compass, but what we should do is kind of go in 4 different directions. So I'll go right 3, up 3, left 3, down 3, and then we'll just kind of connect those points. Kind of looks like an oval. Is kind of, we have that stretched out thing, but we'll notice that no matter where I draw this, our radius is going to be 3. And there's our circle. There's a circle radius 3 with a center of 1, negative 2. All right. The next thing we're going to do is we're going to write equations. We're going to write an equation based upon a drawing. And then we're going to write an equation in standard form given all this information. This will be where we're going to complete the square. Let us start out with writing a standard equation for this circle where I'm given a central point and a point where it reaches to. So we have a center of negative 3, 5, and we have a point on the circle which is 1, 8. Now I'm going to notice we need a couple different things. We need the center in order to come up with our equation. So we need to come up with our center, which means I need to have an h and a k value. I also need to know the radius. If I know those two things, I have the equation for my circle. Well, we're going to notice we already have our h and k values. So if we go ahead and start writing our equation, so we have x in standard form, we have x minus h squared plus that x minus k, nope, we need y in there, y minus k squared is going to equal r squared. I do know what my h and I do know what my k values are. Now, the nice thing is since we know the -3 and 5, we just throw that in for h and k. So we're going to have x minus, now notice we have -3 for our x value, so our h is actually -3. So we have x minus a -3 plus our y minus our k value is 5. We still don't know our radius, so let's just leave that as radius squared. This is the next thing we're going to find, is our r value. Now, if we look back here, we can draw a line for our r value. That's why we're given a center and a point that goes right there. And we're going to notice that this is my radius. The distance from the center to any point on a circle is going to be our radius. It is a distance. So that means we need to get the distance between those 2 points. So to get that r value, we need to realize it is the distance between -3, 5 going all the way to 0.18. All right, just a reminder what our distance formula is. Our distance formula is our x value subtracted squared plus our y value subtracted squared, and take the square root of that. So let's kind of do that in green so we can see it all together. So our distance is going to equal, or our r value is going to equal our 2x values subtracted. So we have -3 minus 1 squared. Now we add, because it's a squared plus b squared. The distance between my y values is 5 minus 8 squared. This is just going to equal, what is that? 4 squared plus our -3 squared. Now just a reminder, when we have -3 squared, that should be a positive 9. Both of these should be positive. So we should result in, well, like I said, we'd have a -4 squared, which is going to be 16, plus a -3 squared is 9, which equals the square root of 25, which I'm pretty sure is just 5. So our r value equals 5. So now we can go ahead and throw that value in. So now we know that r equals 5. We just need to throw that in, and we're done. So we're going to have x, I'm going to change this to plus 3 squared, plus our y minus 5 squared equals 5 squared is 25. I will go back really quick on that distance portion of it. I do want to point out the fact that sometimes we just forget distance formulas. It happens. So what I always want us to realize is this does make a right triangle. And especially in this drawing form, it's pretty easy to come up with those dimensions. We can just do a squared plus b squared equals c squared. Because to get to -3 to 1 is a distance of 4. To get from that 5 to 8, we go up 3. This is actually a 3, 4, 5 triangle. We might have just been able to draw that without doing any fancy formulas and go, oh, r is 5 because it's a 3, 4, 5 triangle. So don't forget about the fact that it comes from right triangle trigonometry. All right, last thing we're going to do is we're going to put x squared plus 6x plus y squared minus 5y equals -1/4 in standard form. Now, remember what standard form looks like, and I'll just show this example. It is x plus a number squared. Actually, it's x minus a number. In this case here, we have x plus 3 squared. And then we have y minus 5 squared. So it's those numbers minus each other squared. So we do have to have squares. That's where we're going to go with that completing the square that we did on the other side. So when we see our x squared plus 6x, so I have x squared plus 6x, I need to turn this into, let's back up real quick, I need this to become our x minus h squared, which means I need to complete that square. So now let's go back and start writing some stuff. So the way I'm going to do this is I'm going to go, okay, x squared plus 6x. I'm going to highlight the stuff that I added in. So remember, this is b divided by 2, so this will be 6 divided by 2 squared, and I need to highlight this because we can't just add stuff in. Let's hold that for a second. Let's do the same thing for our y values. So we have y squared minus 5y. We need to complete the square, so that's going to be plus negative 5 divided by 2 squared. Highlight it again. And that's going to equal a negative 1 over 4. Now the reason why I highlighted those is because it's not balanced. You can't just add something to one side and expect it to be balanced. Like adding a 5-pound weight to the left-hand side, you have to add a 5-pound weight to the right-hand side. So I box these in so I don't forget to add them in on the other side. So the other side, I'm going to add that 6 divided by 2 squared in plus that negative 5 divided by 2 squared. So I added them on the left-hand side. I'm going to make sure I box them in and see that I added them to the right-hand side, so we are balanced. Now, the whole point of doing this was to complete the square with this and to complete the square with this. So this is where we factor. As a reminder, the squares are going to be taken care of on the outside, so we have x plus just the 6 over 2, and that squared is taken care of on the outside. Plus y, we have a minus 5 over 2 squared on the outside. Once again, that square does not go on the inside, it always sticks to the outside. On the other side, we will have negative 1/4, and we're now going to have 6 over 2 squared. Now, you might be someone that's going to simplify that and go, okay, it's 3 squared, but I'm going to notice that 6 over 2 squared is going to equal 36 over 4, and I may want to leave it like that because we're going to note that now we have a common denominator. So I'm not going to actually simplify that, so I have a common denominator. And we're going to notice the same thing is going to work for our next one. Now, negative 5 times negative 5 is a positive 25. 2 squared is 4. We're going to note that all of these have this nice common denominator. So that's why I didn't simplify that 36 over 4. Now let's simplify the left-hand side. Our left-hand side should just be x plus 3 squared plus y minus 5 over 2 squared is going to equal, well, real quick, I'm going to do a little side work here. So we have negative, that equals that. So this is going to be, what, 60 on top divided by 4. So this whole thing just equals 15 on the right-hand side. Now that it's in standard form, I know it doesn't ask for this. I'll box it in. This is the solution. But note, I can add to this on the test. I can say what's the center and what's the radius of, this thing. That question is the same thing as this. So if I ask you what is the center and what is the radius of what I have circled on top, that's the same thing as asking for you to put it in standard form. Because only when it's in standard form do we know where the center and radius are. So our center in this case, let me fix up that E. Our center in this case, now as a reminder, one shortcut is what do I plug in for x to make that x plus 3 0? Well, that would be a negative 3. And then we'll have a positive 5 over 2. Our radius in this case would be the square root of 15, not 15, but the square root of 15. That's it for our circle information. I will note on the homework, there are several of the problems that actually ask you to draw a graph of the circle. I'm not looking for super perfection, so if I'm looking at number 9, it does say determine the center and radius of each circle and sketch a graph. Let me show you a picture of mine. Mine is probably even more than I expect out of you because I did use a compass. But all I really need to see is you plotted that center, and I need to see that you figured out that radius. So don't spend a whole bunch of time on it. This homework's a little bit longer because of drawing all those pictures, and we just need a lot of practice completing the square. So that's why we have kind of a longer assignment for this one. On the back side, I'm looking at 15, 16, 17. Some of those can get a little bit tricky considering they're giving you different information than you possibly might have been given. So I'm looking at like number 17, and we have to talk about midpoints in there to get our answer. So those get a little bit more difficult as you work through those. I also really quickly want to go over question 1. It can cause a lot of confusion. Let me take a picture real quick. So if you don't have a square, so we notice we just have x squared plus y squared equals 16. That doesn't mean that you need to complete the square. That is actually a square already completed, because if you look how I expanded it, it really is saying x minus 0 squared. Notice we don't have any x's. It doesn't say x squared plus 3x. It just has an x squared, which means that is x minus 0 squared, and we have a y minus 0 squared, and that would equal our 4 squared. We're going to notice that kind of crops up a lot. So if you look at the first 4 problems, you should not be completing the square. You should not have to complete the square on the first 4 problems. Completing the square is going to start happening at like 10 and on. So there are no y values, there's no x values, there's only x squareds and y squareds, or they're already completed like you can see in number 2. So don't spend too much time on those first 4. You will not complete the square. Otherwise, that's all I got for you. Sorry it's a little bit of longer homework. Hopefully it's okay, and then we can do well on the test.